Okay, Assalamualaikum and very good afternoon. So we continue our chapter 5, which is DFM and DFA for sheet metal forming. Right. So this is the figure about the bending. Okay, bending for sheet metal. Okay, so bending actually is a process whereby a force is applied to sheet metal which cause it to bend at an angle and form the desired shape. So bend can be short or long depending on what the design required. So basically we use a press brake machine, okay, so that the bending can be automatically or manually loaded. So for this design for this sheet metal design, as a rule of thumb, the distance from the outside of the material to the bottom of the cut off should be equal to the minimum flange length as dia punya diameter is equal to 2.5 thickness of the diameter plus the minimum radius of this radius, okay, radius dekat bend. So for this is the position opening away from bend. So this is the line that you are going to bend this metal. Okay. So yang dekat sini dia punya thickness. So the thickness of the bend must be equal to the thickness of the material. Right? Okay, for this one is the sharp. Okay, this one dulu. This one is the sharp inside the bend. Okay, sharp inside the bend radius, which is not recommended in sheet metal design because they can cause the material flow problems in soft materials and will lead to fracture the material, in which resulted in necking or fracture. So we recommend to use the inside bend radius should be equal to the material thickness. Okay, so avoid sharp corner or the material will tear off. Okay, this figure is about the position holes away from bend. So if the metal sheet has a hole here, so the dimension is about the thickness of the material plus the minimum radius of this bend. Okay, dia punya jarak dia daripada sini. Cara kita nak measure dia punya jarak dia untuk kita nak bendkan metal ni, thickness metal tambah dengan radius bend banyak mana kita nak. So kita beritahulah jarak yang sesuai. Right. Okay, we look at this one first. If the web, what is web? Web is the distance between the hole and each material. Okay, distance between hole and each material. Okay, if the web is a minimum of the thickness of the material, so the hole can be punched, which is less expensive than drilling and deburring. So a web that is less than the stock thickness ataupun thickness material, it will result in a bulge on the blank. So bulge means that swelling. Okay, so bulge condition will increase progressively as the web decreases until there will be a complete breakthrough. However, the bulge is hardly visible until the web is reduced to less than half of the thickness. So we can see this one. Okay, you can see this figure. A narrow web will cause bulging, so we can provide an ear in the blank or include the hole as a notch. What should we do to overcome this problem? So, as a suggestion, if the web here is too narrow, so the profile or the metal sheet of the blank could be changed by adding an ear of sufficient dimension and shape to eliminate the problem. So another suggestion for this bulging, we will it would be to change the counter of the blank to include the hole. Okay, can include the hole as a notch. Okay, the notch could either be pierce or be wide enough so it could be included in the blank without a piercing or notching operation. Okay, for this figure, it illustrates a design that is not desirable for quality or economy. So when the form is inside the blank profile, the material must be torn through the stock thickness and the band radius. So if the part is under stress, this step, okay, this step will likely cause fatigue failure. So in addition, stock tooling cannot be adapted because the flat area adjacent to the form must be held in position during forming, which means extra tooling experience. So this one, it illustrates a possible solution by changing the blank profile to provide a relief for the band. So besides eliminating the change of fatigue under stress, so there is a possibility. Okay, sorry. So there is a possibility of using stock 90 degree. Yeah, okay. We use a 90 degree V punches and dies. So the result are better quality and less expensive engineering charges. So this one is the a cutout is needed to bend a flange. So what is flange? Flange ni dia punya panjang ke sini, panjang dia. Alright. Okay, this is the casting process for metal. Okay, first we need to prepare a mold cavity of the desired shape with proper allowance for shrinkage of the metal, melting the metal with acceptable quality and temperature, pouring the metal into the cavity and providing means for the escape of air or gases. Solidification process must be properly designed and controlled to avoid defect, considering the mold removal and finishing, cleaning and inspection operation. Okay, this is some example of design showing the importance of maintaining uniform cross-section in casting to avoid hot spot and shrinkage. Alright, so this one, hot spot, thick section cools slower than other section, causing abnormal shrinkage. The defects such as void, cracks and porosity are created. So because the cooling rate in region with larger circle is lower, so this region are called hotspot. Okay, so they can develop shrinkage, cavities, and porosity. This one is some defect that happens in corner, angle, and also the section thickness. So look at this design, is a very poor design. So we use a ready or fillet to avoid corner and provide uniform cross section. Also this one, the design that lead to the shrinkage. Okay, so this is the better design. Create a corner and sharp design here. Okay, stagger it to prevent hotspot. Use a stagger it. Avoid abrupt change in section thickness. And maintain section thickness uniform. Okay, this is the DFM design guideline for machining. Use standard dimension, which is 0.252625, and do not design impossible to machine hollows or overhang.